My person that I chose to research is Maud Lenore Menten. She's a Canadian biochemist as well as an organic chemist best known for her work on enzyme kinetics. As mentioned before, Maud Menten was a Canadian biochemist and organic chemist. She was born on March 20th in 1879 in Port Lambton, Ontario, Canada. She died on July 26th in 1960 in Ontario. She's most known for her work on enzyme kinetics. She also made important discoveries contributing to the science of histochemistry, which is the staining of cells with chemicals such as dye. Um, she also did work on enzymes and hemoglobin as well. She spent most of her youth in Harrison Mills, British Columbia, where her mother worked as a postmistress and her father piloted boats. The family also owned and operated a hotel as well as a general store. In 1900, Menten left Harrison Mills, her hometown, to attend the University of Ontario. Menten left Harrison Mills, British Columbia, to attend the University of Toronto in 1900. And then after receiving a bachelor's degree in 1904, she began thesis work on the distribution of chloride compounds in nerve cells, which then led to a master's degree in 1907, where she did further research on the chloride compounds in nerve cells. And then in 1908, she moved to New York because she found it very difficult to find research positions as a woman in Canada. Um, so she became a fellow at the Rockefeller Institute for Medical Research, and then within a few years, Menten decided to pursue a degree in medicine and return to Canada. A fun fact, Dr. Maud Menten actually graduated medical school at a time when women were not legally considered persons in Canada. So Menten had to overcome a lot during her time as a student. And then in 1911, she became one of the first Canadian-born women to earn a medical degree. In 1912, Leonore Michaelis and Menten actually explored enzyme kinetics together at a hospital in Berlin, and the two of them quickly developed a theory known as the Michaelis-Menten hypothesis. And this explained the mechanism and velocity of reversible reactions between enzymes and their substrates. We'll get into that a little bit more later. And then in 1923, Menten accepted a position at the University of Pittsburgh and worked as a clinical pathologist while doing this. Um, she did this because she could not obtain a research professorship in Canada. So then she left to go to Pittsburgh, where she spent the rest of her career. Um, and then in 1944, Menten was the first to conduct successful electrophoresis, which again, we'll get into that a little bit more later. And then finally in 1952, um, even after Menten's retirement from the University of Pittsburgh, she continued to pursue her other research interests and joined the British Columbia Medical Research Institute, where she contributed to cancer research in Canada. As far as accomplishments go, Menten did have quite a few. As mentioned before, she was one of the first women in Canada to be awarded a doctorate in medicine from the University of Toronto, which is a huge deal. She held 6 degrees, all from prestigious universities. She successfully characterized various bacterial strands, including Salmonella and Streptococcus scarlatina, which resulted in an immunization program for scarlet fever. Menten authored over 100 publications, and she was selected for induction into the Canadian Medical Hall of Fame. Another thing that Menten contributed to is the Michaelis-Menten equation. So this studied the enzyme invertase, which breaks down complex sugars into simple sugars. As the complex sugar, sucrose, and the simple sugars, fructose and glucose, absorb a special type of light differently, they were able to measure the rate at which sucrose disappeared, um, and the rate at which fructose and glucose appeared. So basically, their equation reveals that the rate at which glucose and fructose appear depends on three different chemical processes and not just one. So the first being that the binding of sucrose to invertase, the enzyme. The second being the catalyzed chemical conversion of sucrose into simple sugars. And then the unbinding of fructose and glucose from the enzyme invertase, which is the final release. Now, if this modeling of enzyme activity only applied to the enzyme invertase, their equation might have faded over the years, but luckily the equation is not specific to just invertase, and it actually applies to any protein that binds and interacts with something else. Um, and so in this equation, we have V, which is equal to the initial velocity in moles per time. The S is the substrate concentration in molar. Vmax is your maximum velocity, and then Km is your substrate concentration at half of your Vmax. And following her collaboration with Michaelis, Menten continued to contribute to biochemistry as she conducted her own research then at the University of Pittsburgh, where she created a new technique that is still used today to reveal the location of specific proteins using dyes. And given that proteins are too small to be seen with a light microscope, finding them is often a challenge. Um, and so this was when she explored a key method of protein isolation, um, also known as electrophoresis. So Menten was the first to explore a key method of protein isolation known as gel electrophoresis. As far as protein isolation goes, once a protein is found, it must usually be separated from its fellows for further research. Isolating a protein requires removing something that's invisible from a soup of many other invisible things, which was almost impossible to do back in Menten's day. So the fact that she was able to do this successfully is a big deal and was very progressive. So she specifically studied human hemoglobin by using electrophoresis and observing variations in mobility amongst normal and diseased hemoglobin. Um, so Menten's collaborative study, the first on human hemoglobin using electrophoresis, um, showed differences in the human hemoglobin by examining the variations. Um, Linus Pauling, an American chemist, has been famously credited for being the first to use this method for his study on sickle cell disease. However, Menten was the first to successfully conduct this. And then we have the picture on the left, which this is just an example of hemoglobin electrophoresis. So there's two different types of hemoglobin present. You have the A type, which is normal, and then you have the S type, which is sickle. So the A carrier makes both types. An A person with sickle cell will have the S type, and then a normal person will only have the A type. So you can see on the left hand side, it has the phenotypes and genotypes listed, as well as then on the right you see the hemoglobin types present, so S and A, S and then A. Um, and then on the gel electrophoresis, you can see the positions to which the hemoglobins have migrated, um, and then match those up with the hemoglobin type present to figure out whether the person had normal or diseased hemoglobin, which would then possibly cause a disease. Menten also had many outside interests as well. She drove a Model T Ford through the University of Pittsburgh for many years and enjoyed many adventures and artistic hobbies. She played the clarinet. She was an accomplished painter and actually created paintings worthy of art exhibitions. She climbed mountains, went on an Arctic expedition, and enjoyed astronomy. By the time that Menten died, she had mastered several languages as well, including Russian, French, German, Italian, and at least one Native American language. And although Menten did most of her research in the US, she did retain her Canadian citizenship throughout her life. And here's my works cited. I hope you enjoyed some background information on Maud Menten. Thank you.